Assalamu alaikum and good evening, everybody, and welcome to the BEAWorld Student Webinar Session number 11. I, Numaira Iram, am honored to moderate today's session. I'll start by sincerely thanking the organizer, presenter, chief guest, and participants for making this webinar successful. Today's topic of discussion will be smart water management in the UAE, solving water scarcity through engineering. The discussion will last for 40 minutes, and we will have a question and answer session afterwards for 20 minutes. Let me introduce our speaker, Abdullah Tafhim, a student in his second year of electrical engineering at the University of Sharjah, UAE. He has been recognized for his outstanding academic excellence, leadership, and all round achievements. He ranked first in his class from grade 1 to 12, earning 10 proficiency awards for being the top students across all sections of his grade over 12 consecutive years. He was also recognized as one of the Gulf toppers in the Grade 10 ICSC examinations and was honored by Media One for his exceptional performance. Throughout high school, Tafhim won 13 gold, 5 silver, and 10 bronze trophies in hackathons, quizzes, story writing, poetry, Quran recitation, and spelling bee competitions. He, lep- he helped lead his school into multiple inter-school football championships, earning 4 gold, 5 silver, and 1 bronze medal at tournaments hosted by Skyline University College. He also represented his school at the Emirates Aviation University AI workshop and received multiple Best Speaker awards at the BEA World, culminating in the prestigious BEA World Student Leadership Award at 2024. Passionate about engineering, innovation, and sustainability, the film strives to create meaningful solutions that positively impact society. Now I will introduce our chief guest of today's session, Engineer Mohammed Abdulatif, who is working as a senior engineer in power design and engineering at Takai Distribution, Abu Dhabi, UAE. I am confident that today's webinar will be both enjoyable and incredibly informative for career development. I now request Abdullah Tafhim to take the floor and begin the presentation.
All right. Let me share the screen, please. Can you see it?
No, it's not clear.
Is it visible now?
Yes, you may begin.
Yes, visible.
All right. First of all, Assalamu alaikum to everyone. I'm Abdullah Tafhim, and as you heard, I'm a second year student of electrical engineering at University of Sharjah, and today I will be presenting this topic. This is engineering the future and the smart water management in the UAE. So let's begin. First question that may arise to your mind is, what is smart water management? Well, smart water management is the integration of digital technology, such as the Internet of Things, data analytics, and automation into the water cycle to monitor, protect, and optimize water resources. Moreover, it is basically, instead of relying on manual inspections and reactive fixes, a smart water system uses real-time data to make instant, proactive decisions. It transforms traditional water infrastructure into an intelligent, interconnected network. We will discuss this into depth, moreover, into the next slides. First of all, we have to understand the reality. UAE is a hyper-arid landscape. The thing is, the United Arab Emirates is among the top water-scarce countries in the world. I say this because the country has one of the world's highest per capita water consumption of about 500 liters to 550 liters per day. The country is experiencing a rapid increase in population as well, which has in turn resulted in huge demand for water. In 2021, the total water consumption in UAE was 1,754 million cubic meters, with the residential sector accounting for, let's say, 981 million, and the commercial sector being like 378 million. We also see 1 meter annual drop of the groundwater tables every single year. And the estimations say we have about 50 years left until the natural fresh water it depletes at the current rate of consumption. The UAE receives less than 100 millimeters of rainfall annually. With a growing population and booming economy, the gap between the supply and demand is widening, making smart management not optional, but it is existential. It is necessary. Now, first we have to understand what are the three major sectors of water consumption. First, we got private household, then we got agriculture and industries. Let's move over to the private household. Okay, this sector accounts for about 18% of total water consumption in the UAE. One of the largest contributors to water consumption is the use of air conditioning systems, which is in widespread use because of high temperatures almost throughout the year. Most of us are using it right now because of the summer. It gets to unbearable temperatures without the air conditioning. The thing is, an air conditioning system, it not only consumes vast amounts of energy, but also uses large quantity of water that is via chilled water pumps. Desalination plants, they are used regionally to address water shortages. In fact, 70% of the world's desalination plants are found in the Khalij, the UAE, Saudi Arabia, and then Kuwait and Bahrain. But as we all know, desalination it comes with significant environmental concerns. In addition, this country has the world's largest per capita consumption of bottled water of 285 liters per year. The water used to fill the bottles is mainly desalinated water. That means you take the ocean water and you purify it and remove the salts and the harmful minerals and basically make it pure, which costs approximately 11.8 billion dirham annually. In addition, it takes around 3 liters of water in order to make just 1 liter of bottled water. You might think, where might the two other liters go? It is basically used for, let's say, cooling the industrial machinery, the conveyor belts, and let's say the other liter of water is basically used to cool down the things which melt the plastic bottles and blow them into shapes that is usually the normal shapes of the plastic bottles that you see. So, and 1 liter might be, let's say, the wastewater, like the wasted, that cannot be reused, that cannot be fit into consumption bottles. We go on to agriculture, that is the second major sector of the water consumption. Driven by rapid population growth and rising food demand, there's more people, that means there's more food demand, obviously. The UAE is overhauling its agricultural sector, which accounts for two-thirds of national water usage. Traditional irrigation is highly inefficient, that is the spray irrigation. It loses 30% of its daily water volume strictly to atmospheric evaporation just because of the heat. 30% of its water is lost. That will be about 12 to 15 liters per square meter. Now, to mitigate this crisis, the government is driving a dual strategy. The first one being it replaces wasteful spraying methods with advanced drip irrigation to slash the water consumption by 35%. And then the second one is we phase out the water intensive crops in favor of drought resistant varieties sustained by recycled wastewater. So whatever we can grow by efficient irrigation methods, we will grow, and the rest we will just import. Now, the third major sector being the industries. Industrial activities, they make up roughly about 9% of the UAE's water footprint, with the majority dedicated to cleaning the machinery and industrial cooling. While this creates environmental risks through polluted runoff, but it also provides a massive opportunity for water recycling. We will give you examples. The first one being Abu Dhabi, it treats 600 million meter cubes of wastewater per year. But however, it only utilizes the 352 million meter cube for district cooling and green spaces, parks, public parks, and all that. Now, the thing is, you might ask, where does the rest of the water go? Roughly around 248 million cubic meters. Well, it goes to shallow coastal channels and like primarily discharged into the marine environment. It is safe to discharge them because it's purified, but it costs a major loss. It isn't being used due to, so let's say, seasonal fluctuation. You don't need as much in the winter as much as you need in the summer. Some of the crops you don't need it in the winter. The parks, the farms, they require less cooling, less district cooling systems. But then the thing is, the excess water, it might be discharged. But then there's another problem as well. We have lack of a fully connected pipeline network to transport the recycled water directly from urban treatment plants out to remote agricultural sectors and deep desert farms. But to mitigate these issues, we are doing an aquifer recharge. The excess treated water, it is increasingly being pumped into managed underground aquifers. This creates a strategic emergency reserve and uses natural underground storage to prevent water from evaporating. It will simultaneously improve brackish groundwater quality as well. And then the second one is, uh, I said that there is like a lack of a network system to provide the water. So Abu Dhabi is building a massive strategic transmission line and deep tunnel networks. It is called the STEP program, Strategic Tunnel Enhancement Programs. And these networks, they aim to redirect the remaining hundred of millions of cubic meters of water directly to over 4,000 desert farms, completely phasing out the marine discharge that we lose, roughly around 248 million meter cubes of water. Now, the traditional pillars of supply, there are three. There is obviously the desalination. The 42% of the potable water comes from the desalination. There might be MSF or MED thermal plants. That is basically multi-stage flash or multi-effect distillation, where the thing is, in those desalination plants, you heat up the water, you evaporate the water, and then you collect that steam in another tube, and then the salt and everything else is left behind. Basic evaporation, basic desalination. The thing is, the second traditional pillar of supply is the natural groundwater that is depleting at a high rate. And the third one is reusing the treated sewage effluent, that is the groundwater, for irrigation and cooling and parks and all that, drip irrigation and other similar things. These three are the traditional pillars of supply. Desalination, however, alone accounts for 10% of the UAE's total energy consumption. We have a strategy, that is UAE Water Security Strategy 2036, where we use the water efficiently throughout all the sectors. We require a 21% demand reduction. And also 95% of the TSE reuse, that is treated sewage effluent, and we reuse it. Increasing treated wastewater reuse to near total coverage for landscaping, cooling, and industrial applications where you do not need the pure water exactly. And by 2050, we will be integrating water infrastructure with the UAE's broader climate commitment. And we will use less carbon emission systems. Let's say we will transform the desalination projects from a thermal desalination plant into a reverse osmosis one. One of the innovation milestones is solar-powered reverse osmosis desalination. The thing is, UAE is transitioning from energy-intensive thermal desalination, which requires a lot of energy, to a high-efficiency reverse osmosis one. It dramatically cutting off energy used per liter produced. Solar-powered RO units, they enable off-grid small-scale desalination for remote quantities. And Dr. Muhammad Ahmed Dawood's research, it validates the feasibility for arid region deployment. And the carbon footprint reduced by up to 60% versus the traditional thermal plants. What happens in these reverse osmosis, it doesn't require heating or phase change, similar to thermal thermal desalination plants. It doesn't require all that. It is basically a membrane-based pressure system. The high pressure pumps, they force the seawater against a series of semi-permeable membranes. And those semi-permeable membranes, they will only let the fresh water to go through it. And the salt and the rest of the impurities are just left behind. This is Dubai's $920 million Hassian RO desalination plant. It The construction of the first phase, it cost 3.38 billion dirham, and it is a seawater desalination plant at the Hassian complex in Dubai, and it is 90% complete as of now. It is being the information is revealed by the DEWA, the Dubai Electricity and Water Authority. The plant being developed under the independent water producer. It will produce a capacity of 180 million imperial gallons per day. When the first phase, this is just the first phase, and it will roughly open around February 15 of 2027, the first quarter. DEWA plans to add 240 million imperial gallons per day of seawater reverse osmosis capacity by 2030. That is the next phase. And it will bring a total desalination output to 735 million gallons per day. This utility aims to produce all desalinated water using a mix of clean solar energy and waste heat by that year. And reverse osmosis technology, it uses high pressure membranes, basically what I said. It is more energy efficient than traditional thermal desalination methods that dominate in all of Khalij, all of Gulf. And we have to use smart urban landscapes, that is Internet of Things and big data. We will use real-time monitoring. IoT sensors, they will track the flow patterns across entire building complexes, giving facility managers live visibility into consumption by floor or device. We will have automatic leak detection. They will have smart shut-off valves that will detect anomalies and isolate leaks within seconds. It will prevent catastrophic water loss before it escalates. And there will be data-driven efficiency, predictive maintenance scheduling, and benchmarking assets across assets. Now, this is basically it is taken. I have taken this from the 13th annual undergraduate research conference on applied computing. It was done in the American University of Kuwait in 2021. It basically showed. It was done by a group of 3 students, and it showed basically how a system can work like this. Essentially, the smart water management is about taking control of the water usage. Using the Internet of Things, metering devices that allow companies to monitor the water consumption patterns remotely across all area of the properties. You can monitor every single thing. Data on usage is then collected and stored in real time, providing an advanced analysis. The device also provides water performance reports and monitors information continuously throughout the day. In the event of an emergency, the app can detect leaks or blockages and automatically shut off water supply to prevent further damage. Now, this is one of the most effective ways to minimize the water bills and conserve precious supplies. Real-time sensors and meters, they collect data on water flow itself with just one water meter needed to monitor an entire building supply because everything is so connected. Now, if the individual meters are used on specific floors, areas, or devices, they can be monitored. And by connecting electric shutoff valves, the system is capable of turning off the supply and preventing unnecessary wastage immediately using this AI. This proposed system, it consists of 3 main parts. A lower unit that is attached to the storage tank. It has a microcontroller that is the brain of the system. Basically, it thinks where it controls and monitors the entire operation. Now, there will be a Wi-Fi module as well that will be used to communicate and connect it to other parts of the system so that it works as a whole unit. This unit has 5 sensors to measure all the water-related signals. The third unit is a portable mobile application that allows the user or the consumer to monitor and control the system from anywhere using the Internet of Things, just on the press of a button. Basically, just go to your iPhone settings and just in the press of just by the press of a button, you can control basically every single settings that is related to your water supply. There will be ultrasonic sensors, pH sensors, TDS sensors, every sort of temperature sensors and coolers and everything. This is just the example of an IoT server, basically what an Internet of Things can do. It is basically I'll give you a more brief detail on Internet of Things. It is a server. It acts as the centralized brain of an IoT ecosystem. If the sensors and hardware devices are scattered out in the field, they are the eyes and the hands. The IoT server is the nervous system and the brain, where all that data is collected, processed, and translated into action. Now, one of the other innovations is the smart metering. And all of this exists, by the way. It is just not used widely. And if we do use it, then major results can be seen. Smart meters are a cutting edge technology that may assist streamline water distribution. And uh, by recording the consumption data in real time, these utilities can track trends of water consumption and pinpoint spots of over or under use by installing smart meters throughout the water distribution system. This may aid the utilities in maximizing the water efficiency by enhancing the distribution efficiency, decreasing leakage, and minimizing the waste. Generally speaking, the following are the most important aspects of a smart sensor. All of these measurements must be accurate. Let's say transduction system or detection to convert these analytical signals into a measurable electrical quantity that you can see on that digital screen. A suitable measurement and signal processing interface to shape that electrical signal, and then it will be processed using the data processing system, and it will together be calibrated with the system to ensure the measurement is perfectly accurate. And then the autonomous power source to guarantee the non-stop operation of the entire process of this measurement using these digital devices. By giving people access to this water use in real time, smart metering may encourage water conservation as well, because you can exactly track your water needs and your water uses. Consumers could be encouraged to adopt more sustainable water habits if they could see how much water they were consuming and how much it was costing them. Considering more detailed data on water consumption, smart meters may also help increase the accuracy of water bills. You might have less disputes with the SIWA or DIWA. Utility companies and the customers may have fewer disagreements and billing mistakes as a result of this, because it's very transparent. Smart meters may help utilities cut down on wasteful water use, boost productivity, and encourage conservation via their distribution system. These utilities may better serve the customers and communities by incorporating smart metering technologies into the design of their water distribution network. This is beyond the agriculture. This is how you use the TSE, basically the treated sewage effluent. This is treated wastewater. It is no longer just a farm input. The UAE is a pioneering urban and industrial reuse at scale. It is used in urban landscaping, let's say golf course, parks, green belts. They are irrigated entirely with TSE. Industrial cooling, where you are replacing the potable water in HVAC and data center cooling loops by these TSE. Environmental restoration as well, recharging the wetlands and controlling saltwater intrusion into aquifers. This is the smart irrigation and rural resilience. Uh, Basically, this is scaling down the waste. Agriculture accounts for a significant share of UAE water use. AI-driven precision irrigation is changing that. Soil moisture sensors, they can trigger irrigation only when and where needed, so you might not use more water than necessary. AI weather integration adjusts schedules based on evapotranspiration rates. And distributed desalination preserves the water quality in rural and pre-urban zones. The quality of water might be better. The smart irrigation can reduce agricultural water waste by up to 40% while maintaining the same yield of crops. Drip irrigation is the new way. Spray irrigation just wastes too much water. United Arab Emirates, they have taken crucial steps to battle these crises. The government has introduced this new irrigation technique that is more efficient, such as, let's say, drip irrigation, this one. This uses 35% less water. That means 8 liter of water per meter square every single day than traditional spray irrigation system. This country has also moved away from crops that are water intensive, that just waste too much water. Since we are water scarce, we will only build and we will only grow the crops which can align with our goals. It motivates the farmers to install drip irrigation systems. Provides The government can provide subsidy for installation of these drip irrigation systems, further encouraging them. You can educate the farmers on how to operate and maintain irrigation systems, and educate farmers and the general public about long-term effects of water scarcity on agriculture. This is the strategic infrastructure. This is based on storage. You have seen viral videos on Facebook, Instagram, and all over social media. What happens when UAE gets a surplus of rainfall? Those wadis and mountainous regions, they have a flash flood runoff. Dangerous. But then UAE has turned this into something positive. They have constructed over 120 dams and weirs to capture this flash flood runoff, and transform this destructive weather event into strategic water asset. We can capture, store, recharge, and align with the UN SDG 6, that is the Clean Water and Sanitation for All program. According to the words of Suhail al-Mazrou'i, the UAE Minister of Energy and Infrastructure, the lack of fresh water and resources in arid and semi-arid regions around the globe constitutes the major deterrent towards achieving sustainable development. Water is the most limiting and strategically important resource. The future and prosperity of nations is largely dependent on water availability and sustainability. This, hence, is awareness. The conclusive awareness is the biggest challenge for the UAE is not finding different water sources, but decreasing the demand for it and minimizing the water losses so that we can maximize the efficiency. There are currently 100,000 hectares of cultivated land in the UAE, and huge amount of water can be saved by making use of basic water conservation measures. Implementation of effective policies, legislations, and public support is key to success of water conservation programs in this country. The UAE's approach to water scarcity demonstrates that technology and forward-thinking policy can effectively mitigate the extreme environmental constraints by aggressively pivoting away from thermal desalination towards solar-powered alternatives, like that reverse osmosis desalination plant, scaling up cloud seeding programs maybe, and aiming for virtually zero wastewater wastage. Uh, and the country is carving out a highly resilient infrastructure. Moving forward, the final frontier for the UAE's water security will be balancing this rapid infrastructural growth with public demand management, transforming how citizens, residents, industries, and farms they value every drop of water. This is the sustainable vision for 2050. From survival, basically, from these water scarcity to sovereignty. Engineering a circular water economy where every drop is captured, treated, reused, and valued, and how UAE can be a role model for every other countries. Research and collaboration, ongoing innovation, cross-sector partnerships, and public engagement are the engines of lasting change. And basically, the awareness part, call to action, that is smart water management must become the mandatory standard for every new UAE development. The question is no longer can we solve water scarcity. It's whether we act with the urgency the crisis demands. And that will be the end. Thank you.
Thank you, Abdullah Tafhim, for that excellent presentation. You are truly an inspiration to all of us. As a student still assessing my career options, your insights have been incredibly helpful, and I am sure our audience feels the same. We will now open the floor for questions. If anyone has a question for our speaker, please raise your hand, or you may post your question in the chat box. I see that Ms. SM Atar Rahman raised his hand first. You may ask a question.
I have two questions. One is you mentioned, first, I appreciate your presentation. You cover a lot. Uh, you mentioned annual drop of groundwater, average 1 meter. But do you have any record or how much recharge per year, minimum recharge of groundwater? One thing. You
I think,
mentioned
all right.
various types of water desalination by various ways, but do you have any costing for per liter? And by producing this water, you utilize in different sectors, agriculture or cooling areas, but how much return? Producing good saline free water and you utilize it to other sectors, costing and benefit you got. Have you any record? Thank you.
Thank you for the questions. Uh, could you repeat the second question? I couldn't get you. The second question.
You in the UAE, water is desalinized and reused in various sectors. So you have costing of desalination per unit, and with this unit, how much you get returned from the I say either agriculture or industrial sectors. Have you any cross cost benefit ratio?
Basically, the first question that you asked was basically how much water is recharged in the aquifers in the UAE per year. Yes. Uh, so the thing is, I did mention about how the water depletes 1 meter to 1.5 meters every year, but since the 20th century, uh, there has been two reserves: the Liwa Strategic Water Reserve and the wastewater injections scaling. They have caused about 20 agricultural red zones. It has plummeted 20 to 60 meters. But the thing is, the pumping water maximum of 36.96 meters over a 27-month filling cycle has been filled, and a length of fresh water floating right above the native brackish groundwater. So within 27 months, 36.9 meters vertically has been filled. This is after those two programs that the government has taken. Before, it was just only used. The initiative wasn't taken to recharge the aquifers. And about the second one, that is the costing of desalination per unit, and how much return in costing. I haven't really gone into much of a detail, but there is a rough estimate. It is basically from 50 cents in USD to $2.5 per meter cube of water. It can range, basically depending on the conditions, from 50 cents to $2.5 per meter cube. The seawater desalination, that is the cost. About the return, and basically if you take, that is just the capital expenditure. There is also energy consumption, 30 to 50% of the ongoing operational cost per unit. There's pre-treatment and chemicals, and there's lifespan maintenance of every 2 to 5 years. So we have to take every of these things into the costings, and the return, it is basically around 7 to 10% annually of the 30-year life cycle plan. So about 36 cents per meter cube. But and I think it will massively increase after those the reverse osmosis desalination plant that is being built at Hassian in Dubai. But for now, the return is about 7 to 10% annually over the next 30 years. but this is only for the private companies, let's say ACWA Power.
Thank you.
I see Nuzhat Madiyat has raised her hand. You may ask your question.
Yeah, so my question is that we know that OpenAI, Google, and Microsoft, they're all expanding in the Gulf, and the energy consumed by these data centers is expected to double or even quadruple by 2030. So it doesn't seem like the demand is decreasing anytime soon. So how can water be managed to meet data center demands in the UAE when it comes to cooling data centers, and at the same time managing energy and resources for the other industries like households and agriculture?
Basically, in the 2050 Vision 2050 plan, this the rise in the data centers has been taken into account, and basically we do not need fresh potable water for these data centers. We can just use the TSE, which is the treatable sewage effluent, and so basically those wastewaters, they can be recycled and reused into the data centers, and moving on from there itself we can move forward along with it. So basically we will maximize the efficiency in the sectors where it might, let's say in the private households, where we can detect leaks, in the agricultural fields where we can maximize the efficiency by newer irrigation systems. If we can manage water from there, and if we recycle those waters, we can comfortably use them in the data centers and their rising demand. I'm sure, and it's been taken into account in the Vision 2050 of the UA Vision 2050, basically.
Okay, thank you.
Does anyone else have any questions?
I have another question. Interest in UAE, technical personnel or the labor skilled or semi-skilled of Bangladeshis are there working? Not the number you mentioned, just are there Bangladeshis working there in the
Yeah,
water
there's
sector?
a in the water sector.
Yeah, yeah.
I'm not really sure based on the nationalities, based on the percentage of nationalities, but any basically, yeah, any sort of engineers or there will be major water projects, so there can be influx of, let's say, Bangladeshis. But as for now, I don't think there is an increase based on the current political situation. But I haven't really researched onto the nationality part based on working in the water sector.
Another question is desalination only is not suitable for human body. It must be disinfected or to inject some chemical for maintaining the water quality standard. So after using this thing, when you send to the again sea or agriculture field, it will affect the environmental uh, degradation. So if there are any measures they take to stop this thing.
All right. So basically, when water is being the water that is potable water is being disinfected and desalinated, and if there is a surplus of water, maybe it can basically, yeah, it can deter the environment and all that. But clearly, it has been mentioned, it is mentioned that the desalinated water, they are not released back into the oceans itself where there is salt water. It is done into shallow coastal channels, and basically any of the man-made projects that the UAE has. So it is not basically used right back into the ocean. And as for irrigation, I'm sure there are fertilizers and all those chemicals that are being used anyways in the agricultural field. So I think they make it more, they make it suitable for, it is different. Like desalination is primarily used for potable water, 40% of the desalination. And if there is a surplus, then it is being released into the coastal channels. For irrigation, it is there are different channels. They do not cross contaminate or intermix. Those two are different sectors.
Thank you, you.
You're welcome.
Um, Raghib, you may ask a question.
Yeah, so I think in your slides you briefly touched on AI and how it's used in smart water management. Could you like expand on that?
The smart water management.
Yeah, if AI has any role, especially in the UAE or in general.
Yeah, it does basically. So I have mentioned a series of water, basically the use of AI in it. It is basically I have mentioned Internet of Things, and let's say smart metering. Uh, it can be so I basically said these Internet of Things, it is smart and it can rely, so the user, it can control and monitor the system using a mobile phone from anywhere. So basically you are not manually checking every single sensor. The Wi-Fi, the IoT server, basically, which is the nervous system and the brain, they will have a microcontroller, and those microcontrollers, they can automatically detect where the water is being used too much or less than usual, and it can detect those detections. It will process those informations and basically give you a simple notifications that will be understood by the average user. You don't have to see the basically the calculations, how many meter squares of meter cubes of water has been wasted, so what it might be. You're not going to take a pen and paper and solve those problems. Those will be done by AI. Those monitoring will be done by AI, and automated leak detection. So basically there will be shut off valves. So if the AI, those microcontrollers, those chips, if they detect if there is a leak, it will automatically it will those these smart shut-off valves, it will detect the anomalies by itself, and it will isolate leaks within seconds by itself. These are the smart shut-off valves. I have said about this. I have also told about data-driven efficiency. So basically, remote dashboards, usage patterns, and basically all those suggestions and predictive maintenance scheduling, and those benchmarking and everything of those assets, and let's say smart metering, decreasing leakage, and like calculations of all those. AI will definitely be used in all these processes.
Okay, thank you.
You're welcome.
I believe Mohammed Shaheen Siraj has a question.
Yeah, Assalamu alaikum. My question is regarding the contamination of the groundwater. Is there monitoring it by the authorities in UAE?
Uh, Contamination basically by what? Like, can you be a little bit more specific?
No, because in Saudi Arabia, the sewage system network is not complete and is not everywhere in all cities. So there are some septic tanks, you can say, these are giving out, you can say, the untreated water into the groundwater system, groundwater level. So there will be sort of contamination. So is there any way the authorities controlling these?
Yeah, basically, uh, as I told, this Internet of Things, it is basically being implemented. It has that basically all those 5 types, 6 types of sensors. that will detect the pH levels, oxidating reduction potential, and dissolved oxygen levels, specific ion sensors, turbidity, and electrical conductivity as well. And this sudden jump in conductivity, it indicates that salt are leaching into the aquifer. So basically, a lot of salt water is going into aquifer. If that salinity sensors, if the salinity sensors detects a lot of saline or basically salt, that means the groundwater is being contaminated. Then what about pH level? The normal groundwater, it sets at, let's say, a neutral range. If there is a sharp shift towards, let's say, acidity or extreme alkalinity, it can indicate that there has been a chemical spill or, let's say, industrial wastewater leaching into the soil. So these are some of the sensors that can be used. The real world case studies for Dubai municipality's groundwater framework is it has built the network, it has protected the subterranean aquifers, and it has deployed over 74 fully equipped smart monitoring stations across hundreds of groundwater well locations. And the workflow, these stations, they utilize already automated IoT sensors to sample and transmit the data instantly to a centralized dashboard under the Environmental Sustainability Management Department. And there's also contamination targets. It makes those AIs, they make audits for pH and turbidity, dissolved oxygen. What else did I say? Salinity and all that, nitrates, phosphates, and basically you get the deal. This constant data stream, it allows specialists to swiftly pinpoint the specific pollution sources. So where can it be polluted from? They're basically improving and pinpointing to the locations which are the safest. And more than 74 fully equipped smart monitoring stations have already been equipped in Dubai itself, in just one state of across the UAE.
Thank
Does
you.
anyone else? Sorry, you may continue. Sorry.
Yeah, I got the opportunity again, once again. In UAE, rainwater catching and storage facility, they took the initiative, though there is a rainfall is very low and scattered.
Yeah. That's all. That's your question.
This is my question.
All right.
Have there any
Uh,
initiative of rainwater harvesting?
Rainwater has harvesting, yes. Basically, although there is scattered rainfall, but then in the mountainous regions, in those, whenever it rains, it usually rains heavily. And basically, due to global warming and uh, unpredictable climate, there has been a major shift in the climate of the UAE. So yes, it does make sense to have something that is basically rainwater harvesting systems, and the UAE has already radically shifted how it manages the rainwater. So rather than treating this stormwater as a hazard to, let's say, drain away, rather than them panicking that it should be drained away, the nation treats it as a critical asset. Multi-billion dirham rainwater harvesting and storage facility initiatives. There has been the National Dam Infrastructure Network. These are tools used by the UAE to capture those mountain and wadi runoff before it evaporates or escapes into the sea. Those wadis are basically the villages located between the mountains where it's like a very hazardous flash flood flow of water where they catch it before it evaporates by itself. Uh, Basically, I have mentioned already about 103 federal dams, barriers, and lakes. More than 150 total barriers across the nation has been made by the Ministry of Energy and Infrastructure. It is basically a whole grid. They have seen where the wadis, the rainwater hits the most, and they have basically built all these dams, barriers, and basically a total amount of barriers. And these facilities, according to Gulf News, it can hold approximately 80 million cubic meters of water. So yes, it's a lot. And I've gone to these dams last winter itself. Basically, my friend, he lives in, he is a local in Wadi Al Hilu. So basically, 2 years ago, there were massive hazards of the water basically flooding their entire houses. But now the dam has been built there. There has been Wadi Ham Dam in Fujairah, Wadi Shauka Dam in Ras Al Khaimah, and then even in the Hatta Dam in Dubai. Even in Ras Al Khaimah, I think Wadi Al Bih, there is a dam. So all these dams are being built just to catch that rainwater, just to have that rainwater harvesting basically. Even across 13 residential areas, they have a package, those projects where they have those national rainwater infrastructure. Yeah.
Another subsequent question. Do you think UAE water management system is much more better or improved than the other arid country or region?
I think UAE's one is severely better because it has UAE has always been leading, where everybody follows UAE as a role model and example. They were the first for all these AI, Internet of Things, and basically all of these technologies to be basically all these technologies to be admitted in these types of in these fields and aspects. So yeah, basically, yeah, UAE is a leader, and yeah, and UAE does recognize that it has limited land area. It also has a limited population capacity. So it basically maximizes the efficiency. It follows a very maximizing the efficiency rule, where it knows how much it has and basically doing the best within whatever it has. So it is perfect for a country like UAE. It is definitely a leader.
It seems that there are no more further questions from the participants. Wait, I think there is someone else. Wait, no. Thank you all for your active engagement. I would now invite Engineer Ahmed Hossein Chaudhary to share insights on today's session.
আসসালামু আলাইকুম সবাইকে, যারা ইউএই থেকে এবং ইউএইর বাইরে থেকে পার্টিসিপেট করেছেন এখানে এই প্রেজেন্টেশনে, ওদেরকে সবাইকে সালাম জানাচ্ছি এবং ধন্যবাদ জানাচ্ছি। আপনারা কি আমার কথা শুনতে পাচ্ছেন?
শোনা যাচ্ছে, পরিষ্কার।
প্রথমেই আমি খুব অ্যামেজড অ্যাকচুয়ালি তাফিমের প্রেজেন্টেশন দেখে। ও সেকেন্ড ইয়ার ইলেকট্রিক্যাল স্টুডেন্ট এবং আমি নিজেও ইলেকট্রিক্যাল ইঞ্জিনিয়ার। আমি টাকা ট্রান্সমিশনে জব করি। আমি ওর যদিও ওর স্মার্ট ওয়াটার ম্যানেজমেন্টের সাথে ওর কোথাও সম্পর্ক নেই ওর একাডেমিক ইয়াতে, কিন্তু ওর প্রেজেন্টেশন এবং ওর যে নলেজ, এটা দেখে আমি খুব অ্যামেজড এবং ওকে খুব ধন্যবাদ জানাচ্ছি। ও ওয়েল প্রিপেয়ার্ড ছিল এবং ওর যে মিস্টার আতার রহমান সাহেবের যে প্রশ্নের মধ্যে এবং ওর আনসারের মধ্যে যে ফারাকগুলো সেটা আমি দেখছি। এটা হচ্ছে ও তো এক্সপিরিয়েন্স না, ও স্টুডেন্ট এখনো, এবং আমরা ওর কাছ থেকে অত স্পেশালিটি আমরা আশাও করি না। এনিওয়ে, আই এম টোটালি তাফিম, তুমি খুব ভালো করেছো এবং তোমার ভবিষ্যতে তোমার আরো তুমি ভালো করো তোমার লাইফে, এবং it is just extra quality actually to just present something so amazingly. নুমাইরাকে ধন্যবাদ জানাচ্ছি এই প্রোগ্রামের মডারেটর হওয়ার জন্য, এবং এটাই, আমি আর বিশেষ কিছু বলতে চাই না। সবাইকে ধন্যবাদ।
Thank you, sir. I will now invite Dr. Sajid Hossain to share insights on today's session.
Thank you very much. Needless to mention that today's presentation was successful in multi dimensions. It's like the presentation, the English language, the pronunciation, the fluency, and coverage of the information. Congratulations, Abdullah Tafhim. You are, I guess, you are in second year, so therefore you will be around just beginning of 20s. So it is proved that the new generation, if guided properly, then they would definitely guide the whole society and new world. Very good. You have covered. It reminds me because I'm a marine engineer. I sailed in ocean-going ships for 13 years, 1980 to 93, and after that, 30 years served in Bangladesh Marine Academy. Retired as commandant 1 year ago. First, I would like to share in this opportunity. It will take only 1 or 2 minutes. In our first ocean-going ships, because everything was new. So number one, water. From where the water will come, water everywhere, not a single drop to drink. From seawater, using the hot water from the engine, it gets evaporated in a fresh water generator, and then it is condensed again by flowing normal water, that is cooler seawater. And after that it becomes distilled water, no taste. Therefore, adding sodium hypochlorite solution at a rate, and then 20 tons every day for 40 persons. Very comfortable. We used to have more and more storage. And UAE, in 1980, when we were crossing the ports nearby and touching the ports, various ports, crossing the Suez Canal and going out to Atlantic, all these places used to be empty, only sands. And as the years passed by, it used to be becoming green and green. How much green has become now? Today's our future professional, Abdullah Tafhim, you have really highlighted the technological advancement. Even you have also pointed out that the massive information management by AI. AI has come to assist the human capacity. As an electrical engineer, you have shown that electrotechnology is really has attained that excellence, and you have covered, I think, in agricultural field, in household, in where not. Therefore, wish you best of luck. That today I believe that the audience received the information in a very smart way. I will finish by saying your topic starts with smartphone, smart everything. What is smart? Smart is something what is planned in your mind, and definitely it's going to happen at correct time, correct measurement, correct everything. No dispute, no offset, nothing. Everything is set as if human computer is working, and therefore something is planned and that is achieved. Very good. Okay, so best of luck. You have shown that really we are living the world on some smart hands. Thank you.
Thank you, Dr. Sajid Hussain. Now I will invite our chief guest, Engineer Abdul Latif, to share insights on today's session.
Assalamualaikum. Thank you, everybody. Okay, this presentation, what for today's presentation, actually, basically my opinion, not opinion, it is a theoretical and bearing a lot of perfect and correct information. That is fine. There is no problem. And it was very nice and I appreciate it. Same time, actually, as usual, this type of presentation, I think here is a lot of our engineers, they know it was introduced first time by me only. I have a suggestion that we should have some practical presentation. What is that? Say for electrical power and water, there is a source, means generation, then transmission, then distribution up to the utility. In between, there is a lot of things. So like electrical power, water, also transmission, distribution, everything is there. For example, what is the practical? Here he mentioned sensor, okay, temperature sensor, for example, how it is working. We know that temperature sensor and another one leak detector. Once there will be leak detected, the alarm will go to the maybe control center, okay. Then it will, within second, it will shut down like a power transmission distribution. If there is a fault, it will it will open the circuit breaker to switch off the power. Now, my question is water transmission distribution, how it is shutting down the water flow. How? This is the practical. So, like a temperature sensor, the sensor is sensing the temperature, but this temperature is not going to the destination to show that how much temperature, because temperature cannot go from the source to the destination, from the sensor to the destination. There is a transducer, definitely. Actually, my opinion, I will recommend the organizer with the theoretical presentation, arrange some most practical and particular presentation so that the professional who will work in this field, he will be benefited. But for the student, this is perfect. Thank you very much. No more from my side.
Thank you, Engineer Abdulatif. With that, we conclude today's session. Thank you all for joining us, and we look forward to seeing you at our next webinar. Have a wonderful evening.